Okay, this next section is called conics. And what a conic section is if you have a cone and you slice that cone, let's say we slice it right here. If you think of that in 3 dimensions, it makes an ellipse. Okay, so an ellipse is a conic section. Okay, if you take a cone and you slice it like this, what you end up with is a parabola. And you can slice, if we take 2 cones and slice it like this, we get what's called a hyperbola. And of course, you could take a cone and cut it straight across and you would just have a circle. So ellipses, parabolas, hyperbolas, and circles are all related because they're slices of a cone. So I'm going to go through all 4 of them one at a time and show the relationship and how they all come from a cone. So we've already dealt with parabolas, but now I'm going to deal with it just a little bit differently in the context of a cone. And this context, this is actually, there's a lot of use for this. It's like an ellipse is how the planets orbit and how comets come in around the sun. If this was the sun, Halley's Comet would come in around it, something like that. And hyperbolas, there's lots of use for these types of equations. Okay, first of all, we have to go to the back. Go to the back of this, and I want to show you a few things. Here's what we've been doing. Let's just say, as an example, we've had something like this. Y equals, I'm just going to make something up, x squared plus 4x. Okay, that right there means it crosses the x-axis twice. So I already know that it's going to cross here and here, and since this first term is positive, it's going to look something like that. So I already know a general idea of what it's going to look like. It's going to be a parabola pointing up. Okay, well, the things we have to find are the zeros, we have to find the vertex, and now in the context of conics, we have to find a few more things. There are a few more things that define that. But first, let me remind you how we did this before. We completed the square. There's no extra number out here. In fact, so what we would do is cut this in half and then square it into the whole. So 2 squared is plus 4. If I add 4 to one side, I have to add 4 to the other side. And now we have y plus 4 equals, and then this was how it factors right here, that 2. So x plus 2 all squared. Okay, this gives us the vertex. That 0 is -2, that 0 is -4. So our vertex of this was at -2, -4. Okay, that's how we started. So then we could start specifically graphing this. 1, 2, 1, 2, 3, 4. Right there was the vertex. And then this was the general slope. It was 1, so there's no stretch anywhere. There's no stretch on the x, there's no stretch on the y. So the first point's going to be the home base, 0, 0. Then it's going to go 1, 1 because we remember that. Over 1, up 1, over 1, up 1. And then the next one would have been 2, 4, and 3, 9, and so on. So we could have gone from the center over 2, up 4. Over 2, up 4, and we have 5 points of this parabola. So there's the vertex. That was one of the things we had to do. And then another thing we typically had to do was find the zeros. So here was the equation originally. We have all kinds of ways to find the zeros. We could factor it. So really we're saying 0 equals x squared plus 4x. I would just put that in the quadratic formula, A, B, C. Since I have that program on my calculator, that's by far the fastest thing to do. If you had your own calculator and went back to that video where I showed you how to program it, that would be the fastest thing for you to do. I would go to program, go down to quadratic formula, because that's what I called it, put in A, program, quad, put in A is 1, put in B is 4, and C was 0. And it will tell me what the zeros are, 0 and -4. So the zeros are 0 and -4. So that means that one is x is 0, y is 0. And that one is when x is -4, y is 0. So there's the zeros. If you don't have that program on your calculator, we could have factored it, or we could have just used the quadratic formula. So the quadratic formula okay, so negative b would have been -4 plus or minus -4 squared minus 4 times a is 1 times c is 0, all divided by 2 times 1. Okay, that's 16 minus 0, so we have -4 plus or minus the square root of 16 over 2. So this one is -4 plus 4 over 2, so that's 0, just like the quadratic formula got. And this one was -4 minus 4 over 2, so that's -8 over 2 for -4, just like the quadratic formula got. So you could have done the quadratic formula by hand and got 0 and -4. And then the last thing we could have done was factored it. Y equals x squared plus 4x. That's an easy one to factor. Take out an x. As long as it's equal to 0, each factor equals 0. So x equals 0, that's one of them, just like the quadratic formula got. And there's the -4, just like the quadratic. So you have options on how to get the zeros. We can factor it. We can use the quadratic formula either by hand or in our calculator. Or those are probably the main two things. Okay, so that's what we've been doing. There's more. So let me show you what really the characteristics of a parabola are. So I'm going to change colors here. Okay, I'm going to make a parabola. I'm going to call this right here the vertex. Now, in math circles, the vertex is usually not called x and y. It's usually called hk, because x and y sometimes refers to the x and y axis. So that point's going to be called the point hk generally. Okay, so we have a parabola going around that thing. Let me just draw a general parabola. Okay, inside this parabola is also a dot called the focus. Now, this is where you would put a TV, if you had a satellite signal up here and it was bouncing a signal down and it hits this parabola, it hits the focus. If it comes over to there, it hits the focus. If it comes down to there, it bounces it to the focus. That's why when you see a satellite dish, it always has the receiver in the middle. Well, that receiver is right mathematically where the focus is. So all of the rays, all of the TV signals, all of the music signals coming from a satellite get bounced right to there, so that that's how the dish captures all of the radio waves. Okay, so it's got a focus. You can obviously tell that there's mathematical engineering importance for that point. You got to know where to put the receiver on a satellite dish so that it receives all of the radio waves. Okay, so we have a focus point that we're going to be asked to find. However far the distance from the vertex to that focus point is represented by the letter P. That's a lowercase p. So from the vertex up to the focus is a distance p, and then there's that same distance, whatever it is, that same distance, let's say it's right here. There's a little straight line that goes across there, the same distance. If it from the vertex up to the focus is p, the vertex down to this line is also p, so those two distances are the same, and that dashed line is called the directrix. Okay, here's what the directrix and the focus, and this is how you get how wide your dish should be to match up with this focus point. I'm going to put a point on this dish. I'm going to just call it a point, any point. We'll call it point A. Okay, this is always true. The distance to the focus and the distance to that, looks like my directrix maybe should have been down a little bit further. Let me put the directrix down here. Because the definition of a parabola, the distance to the focus and the right angle distance to the directrix are always the same. that distance and the distance to the directrix are the same distance, no matter where you put P. See, that helps decide how wide this dish should be. So if I put point B over here, this distance, that distance down to the directrix at a right angle are the same no matter where you put B on that parabola. If I extend it out just a little bit more and have this be point C, okay, the distance to the focus to that point, to any point on this parabola, is the same as the distance down to the directrix. Those two things are the same. So if we could measure this, we know how the curvature of that parabola. So the new equations as far as a conic is concerned is we're going to need to find the vertex. We'll do that very similarly, but we also have to be able to find the focus. We also have to be able to find the directrix, and then we also have to be able to find the zeros. So we're going to find the vertex, the zeros, then also the focus, and also the equation of the directrix. Well, that's going to require a few more equations. So it's going to require two of them actually. So here's the first one. Here are the general parabola equation. It has more than just the vertex and the zeros in it. It has more than just the vertex in it. It looks like this. There's actually two of them, and I'm going to split this note thing here in half. Okay, one of them looks like this. Okay, now notice if we squared all this out, this would have an x squared. So the x is ending up going to be squared. Now, this is the formula. I don't want to mess up the main formula while I'm explaining it. So if we multiplied all this out, the x would be squared and the y would be single. Okay, that's telling you that it's going to cross the x-axis twice and the y-axis once. Potentially the x-axis twice and the y-axis once. So crossing the x-axis twice means it's going to have two dots there and only cross the y-axis one time. That means it's going to look something like this. It's an up parabola. This is the kind that we've been dealing with all the time. Okay, this P is going to have something to do with the focus, and I'll show you what that does in a minute. But if P is positive, if this P number right there is positive, then it's opening up. If we have two x's and a y and the P is negative, then it opens down. So that P number, whether it's positive or negative, if the P is positive, up. If the P is negative, it's going to open down. Okay, so this is the form when it crosses the x-axis two times, but all parabolas don't necessarily have to do that. That's all we've been working with before when we're just doing parabolas as algebra. But as a conic, they can also go sideways. The way you get the sideways one looks like this: y minus k all squared equals 4p x minus h. It could look like that. Now, it looks very much similar, but now it's the y that ends up getting squared, and it's the x that ends up being to the first if we were to multiply it out. That means it will touch the y-axis twice and the x once. If it's going to touch the y-axis twice, the zeros are on the y-axis like that. Okay, if we're on a grid, this is the positive direction going that way. So if P is positive, it opens to the right. If P is negative, it opens to the left. So again, the sign of P is a positive opening or a negative opening. If it's this way, it's a positive opening or a negative opening. Okay, with that, let's go and try some examples that are on the front now. Okay, right here I can tell that this is going to cross the x-axis twice because the x is squared. So in my mind, I already know it's going to cross the x-axis and the x-axis like that. It's either going to be pointing up like this, or it's going to be pointing down like this, depending on whether the P, so if P is positive, it's going to look like the blue one. If P is negative, it's going to look like the red one. Okay, they want us to find the vertex, the focus, the directrix, and the x-intercepts, or the intercepts if they're on the x or the y axis, basically the zeros. Okay, well, let's see. First of all, let's get this thing in some kind of different format so we can solve it for y. I'm going to move everything to the other side. How about I move the 4y to the, I'll move the 4y to the other side. So if I do that, I'll put it down here. Moving the 4y to the other side, well, I'll go ahead and move the 3 to the other side also. It'll be negative 4y minus 3 equals, what do we have left over here? X squared plus 4x. Oh, wait a minute, I'm doing it the old way. Let's scratch that. We want to get the focus and the directrix. So let's get one of those formulas going. So when we take a look, we got the x squared. We got to know the form that we want to go to. We want to go to this form with this 4p. Notice the 4p is not on the squared piece. It's on the single piece. So here's the format we want. We want x minus h all squared equals 4p y minus k. So I want to get it in some kind of format like that. Okay, well, I am going to complete the square over here. So let's go ahead and do what I was going to do now. I just should have set that part up. So let's go ahead and move the 4y and the 3 to the other side. So we've got negative 4y minus 3 equals x squared plus 4x. You know, maybe so that it fits this, I'm going to just turn it around. I'm going to put the x things over here and the y things over there. So let me switch it around so that it matches that. X squared plus 4x equals negative 4y minus 3. So see, now all I'm going to do is try to concentrate on this side first so that it looks like this. I want to complete the square, basically. Okay, completing the square. Cut that in half, square into the whole. So cut in half is 2, so I'm going to add a 4 to that side. If I add 4 to this side, I add 4 to this side. Okay, now we have it completed. So this 2 is the completed square. We have x plus 2 all squared equals negative 4y, negative 3 plus 4 is plus 1. Okay, see how I have this side now completed? It says x minus h all squared. This is going to be part of the vertex. That makes the vertex negative 2. That's what that minus is doing. Okay, over here, the y is by itself. So I got to factor this up so that the y can be by itself. So I'm going to divide out the negative 4 and see what's left. Well, this first piece divided by negative 4, it leaves the y, and 1 divided by negative 4 leaves a negative 1/4. Okay, so we have done some manipulation to the problem. I completed the square over here to get this one to look right, and then I got the y down to what's a single so that the y could be by itself in this vertex form, so I can see the vertex. Okay, see, this was the y. This is one of the stretch numbers that we were doing last time, but we're not going to use it that way this time. Okay, here's the vertex. Whatever makes this 0. So this is at negative 2, and this is at positive 1/4. So the vertex is at negative 2 1/4. That's one of the things that they asked us to find. Check. There's the vertex. I could plot that now if I wanted to. Negative 2 up 1/4. It's right there. Okay, the next thing, I don't need to find one point to the right and one point to the left. The next thing I want to find is the focus. Okay, so from my drawing back here, the focus is p units up from the vertex, and the directrix is p units down from the vertex. So if I could just find p, then I can go p units up from this and have it. Okay, well right here, this is in the 4p spot. So that number is 4p. So that gives me a little equation. 4p equals negative 4, divide off the 4. P is negative 1. Okay, that means from this point up, okay, negative 1. P is negative. Means it's going down. Okay, so that means the focus is 1 unit down from the vertex. Okay, the vertex is at negative 2, 1/4. So if I come down 1, there's the focus. It's 1 unit down. So the focus is at negative 2, and 1 less than 1/4 is at negative 3/4. There's the focus point right there. Then the directrix. The directrix is 1 unit up from there. So if I go up 1 unit, the directrix is that line 1 unit up from there, like this. So I'm going to go 1 unit up from the focus, and we need its equation. Well, it's a straight line, so it doesn't have x's and y's. It only has which axis it's crossing and where. Okay, it's crossing the y-axis, and it's crossing it 1 unit up from this will be at 1 1/4. That's the equation of the directrix. Okay, and then I need the intercepts. Well, let's see. We have a couple ways that we could do this. I'm just going to go back to the original equation and solve it for y. So on the original equation, if I move the 4y to the other side, it would have been a negative 4y equals. So I moved the 4y to the other side, so that allows the x squared to stay there, the 4x to stay there, and I'm going to leave the 3 on that other with all of the other stuff. So all I did was take this 4x and move it to the other side. Now I'm going to divide everybody by negative 4 so we can solve it for y. So divide by negative 4, divide by negative 4, divide by negative 4. So this would have been y equals negative 1/4 x squared minus 1x minus 3/4 if it was in standard form. Okay, I like this form because I can now find the zeros really easy. 0 equals that. So A is negative 1/4, B is negative 1, and C is negative 3/4. Okay, of course, I would just put that in my calculator, but if you don't have your calculator, you're going to have to do this part by hand. So negative b, so that's going to be 1, plus or minus b squared, so 1 squared is 1, minus 4 times negative 1/4, that's the a, times the c, negative 3/4, all divided by 2a. 2 times negative 4th is negative 1/2. Okay, so if you don't have a calculator, we're going to have to do it this way. So let me see what's this number inside there. Any calculator can do that. So inside there I have 1 minus 4 times negative 1/4 times negative 3/4. Inside there is 1/4. So that turns into 1, let me get a piece of scratch paper here so I can keep going. So it's going to be 1 plus or minus the square root of 1/4 over negative 1/2. Okay, I left that as a fraction because the square root of 1/4 is 1/2. So this turns into 1 plus or minus 1/2 divided by negative 1/2. Okay, this is 1 plus 1/2 divided by negative 1/2. So that's 3/2 over negative 1/2. The denominators are gone, so it's 3 over 1, so negative 3. This one, 1 minus 1/2. over negative 1/2. Okay, 1 minus 1/2 is 1/2. And 1/2 divided by negative 1/2 is negative 1. So the zeros are at -3, -1. Of course, if you had your own calculator, you could just run the program. I'll help you with the program if you don't have it, but you do have your own calculator. So A, -1/4. B was -1 and C was -3/4. Sure enough, -3 and -1. So there's our zeros. -3 and -1. So it's crossing at -3, 0, and -1, 0. So here's what we want to identify on all of this. It's going through those points. It's going out there like that. So there's the vertex, there's the focus. Now if we put any point on that right there, if we put a point P, the distance there and the distance there are the same. Those two distances are the same thing. Okay, so here's what we're looking for. We're looking for these 5 answers plus the picture of that. Let's take a look at number 2. Okay, number 2 now has something different going on. Notice the y is squared. Okay, that means it's going to cross the y-axis twice. Something like this. If the p ends up being positive, it's going to go to the right. If the p ends up being negative, it's going to go to the left. So it's going to go one opening to the right or opening to the left because the y is squared. Well, that means we want to get it into this form. We want y minus k squared equals 4p and then x minus h. The 4p always goes with the single, not with the double. So I want to complete the square on the y over here. Okay, let's get the y things together here first. So we have, looks like I've got -y squared plus 4y. So that's this one and this one. And I'm going to move the other pieces to the other side. Okay, so I'm going to take that and make it -4x minus 12. Now, I don't particularly like completing the square with a negative in the front, so I'm just going to multiply everybody times -1. That'll make that y squared minus 4y, 4x plus 12. That's, as long as we do it to all the pieces, that's a legal step. Okay, completing the square. Cut that number in half, -2. Square that into the whole. So -2 squared means I got to do a plus 4 there. If I do a plus 4 on the left, I got to do a plus 4 on the right. Okay, so here's our completed square. Y minus 2 all squared. And over here we have 4x plus 16. Okay, I got this part right. All you got to do is complete the square for that part and you have it in that form. Over here we got to clean up the x. So I'm going to divide out the 4. I'm going to factor out the 4. Okay, there's our equation. Here's our vertex. That's at 2 and that's at -4. So our vertex is at -4, 2. That's one of the answers. So 1, 2, 3, 4, 1, 2. Right there's the vertex. This spot right here is in the 4p spot. That's equal to 4p. So 4p is equal to 4, so therefore p equals 1. Okay, that's a positive. That means it's opening to the right. Okay, let's see. So that means the focus is 1 unit to the right and the directrix is 1 unit to the left. So right there's the focus point. That's the vertex. And the directrix is right here, 1 to the left of that. That's what P does. P identifies both the focus and the directrix. So here's our focus, 1 unit to the right. So it was to the right -4. So it'll be at -3, 2. That's that point right there. The directrix, Now see the directrix is crossing the x-axis. So the directrix equation is x equals where it's crossing at -5. So we got the vertex, the focus, and the x-axis. So now I know it's going to open this way. Okay, I just got to get those zeros. The zeros work the same way as they would with, you put it in the quadratic formula. So let's go see if we can't set all of this up this time, but we'll solve it for x instead because we want to find two y's. Okay, so let's see here. Coming up here to the original, I'm going to move everybody see, over here we solved it for y to get x. Here we're going to solve it for x to get y. So I think I'll leave that 4x sitting there and move everybody else to the other side. So I'll move the y squared to the other side. I'll move the 4y to the other side. And I'll move the 12 to the other side. Divide everybody by 4, so we have 1/4 y squared. 4 divided by 4 will be 1. 3 divided by 4 will be 3. And we'll set that one to be 0. Now that's A, that's B, and that's C. Okay, negative B plus or minus B squared minus 4 times A times C divided by 2 times A. Okay, negative 4 times, okay, first of all, it's 2 negatives, so this whole thing will be positive. So that's 1 times 3. So this is 1 plus 3. If you put all that in your calculator, it'll give you 3. So we have 1 plus or minus the square root of 1 plus 3 is 4. 2 times the fourth will be 1/2. So it looks like we've got 1 plus 2 divided by 1/2. And we've got 1 minus 2 divided by 1/2, because the square root of 4 is 2. So here we have 3 over 1/2, and here we have negative 1 over 1/2. Okay, so I think I'll fix this one first. We've got 3 over 1/2. 3 divided by 1/2. How many 1/2s are in 3? That's 6. Or you could say 3 times 2 over 1. Remember, when you divide, you could just flip it over and multiply. So that one is 6. So this equals 6. That's one of the zeros. Negative 1 over 1/2. 1 over anything, you just flip it over and you have it. So this equals negative 2. That's the other zero. So our zeros here are 6. Okay, so that means it's going to be up 6. It's gonna cross right there at 6. So that's 0, 6. And then the other one is at right here at negative 2. So that's at 0, negative 2. So be careful when you answer these. See, it's a little bit different order. Over here it's crossed. These aren't really zeros, but we can call them that. There it goes. And it should still make sense. If you put P anywhere on there, the distance straight down to the directrix should be the same distance as the focus. That point and that distance and that distance should be the same. Or if you put it way over here, that distance and that distance are the same. So it doesn't matter if you're far away or short. This equation describes the curvature of that parabola. Okay, it's just practice. You just got to go through the process and practice them. This one is a y squared. That means it's going to look something like this. It's going to cross the y twice. It's either to the right or to the left. So the first thing you got to do, get in your head, is what's the general form. Once we have the general form, we write down that general format. It's going to be y minus k squared. And then the 4p is on the single. So we're going to have to complete the square on this piece. I'm going to put all the y's here. So I've got y squared plus 11y. I'm going to put everything else on the other side. So I'll move the x to the other side and the 28 to the other side. So it'll be minus x and minus 28. Okay, we cut this in half, 11 halves. Square it into the whole. 11 squared is 121, 2 squared is 4. So I added 121 fourths, so I'm going to add 121 fourths. Now, leave these in fractions. Do not make these decimals. I want to see these as fractions. So here's our vertex, y minus 11 halves all squared. Okay, so now you can use your calculator to help with this. Negative 28 plus 121 fourths. Just put it in. Negative 28 plus 121 fourths is 2 2/5. So it's, 2 1/4. So 9 fourths. So we have negative x plus 9 fourths. Okay, to get this 4p spot, we need the x to be by itself, and it has this -1 on it. So I'm going to factor that -1 out. So factoring out the -1 leaves x minus 9 fourths. Okay, there's our vertex. 11 halves and 9 fourths. That's the answer to the vertex. The x is 9 fourths, the y is 11 halves. So we can plot that. 9 fourths is 2.25, so it's over 2.25 and up 5.5. 2.25 up 5.5, so that thing is right about there. Okay, now I'm noticing that the p is going negative, so it's going to open in the negative direction. So I'm just going to put v right here. That's my vertex. This is good enough. You can just give me the actual answer to the vertex. Okay, right here, that's in the 4p spot. So 4p is equal to -1. So that when we divide all that, we got -1/4. So it's 1/4 in the negative direction to the focus. So the focus is 1/4 in, so it's right there, and the directrix is 1/4 the other way. So this is a pretty tight one. So there's our picture. The focus is 1/4 to the left of this spot. So the one that's going sideways will be the first one. So I got to go 1/4. So 9 fourths minus 1/4 is 8 fourths. So it's at 2. The directrix is 1/4 this way. So it was at 2.25 and it was at 9 fourths, and I got to go 1/4 the other way. That'll put it at 10 fourths. It's crossing the x-axis. So 10 fourths is 5 halves. That's the equation of the directrix. So there's 3 things, and I already know basically what it's going to look like. It's going to come something like this. Well, I'm going to find the 0 so I can actually plot it in there a little bit tighter. Okay, so let's come up here and solve this thing for x. I'm going to leave the x where it is, put everybody else on the other side. So I've got x equals, okay, moving that to the other side will be -y squared minus 11y, move the 28. Okay, there's the a, b, and c. So -11, so there'll be negative b, so there'll be positive 11, plus or minus 11 squared, minus 4 times a times c, all over 2 times a, so -2. So I need to get this number, 21 minus all that. I'll just use my calculator and type it straight in. 121 minus 4 times -1 times -28 is 9. So we have 11 plus or minus the square root of 9 over -2. So we have 11 plus or minus 3 over -2. 11 plus 3 is 14 over -2, so one of them is at -7. And 11 minus 3 is 8 over -2, so the other one is at -4. So -7 -7 doesn't seem right. It's way down here. Did I make a mistake? Let me put it in my program to see what it says. -1, -11, and -28. -7 and -4. So I must have I must have made a mistake on the vertex. Did I get one of the negatives wrong? The vertex is probably down 11 halves instead of up 11 halves. That would be the y. Did it get? Oh yeah, that was a plus right there. Plus. Okay, so it's down here. 2 and 2 down 5.5. Right there's the vertex. The directrix is still right there, but now the focus is down. So 2, right there's the focus. Okay, now my zeros are at -7 and -4 going, so that's the focus. So that a small p makes it steeper, is what's happening here. So those two places where it's crossing the axis, it's crossing at 0, -4, and it's crossing at 0, -7. And there are the 5 answers that we want. Okay, one more. This one is an x squared, so that means it's crossing the x twice. It's either up or down. That means I got to complete the x minus h all squared. I got to complete the x's, and then the 4p is with the single, y minus k. Okay, first let's complete the x's. So over here I've got, how about we go -x squared plus 2x, move everything else to the other side. That gives us -3y plus 10. I just rearranged it. I left the x's where they were and moved these to the other side, changing their signs, but I don't like having leading off with a negative, so I'm going to call that positive x minus 2x, positive 3y minus 10. Multiply everybody by -1, because I just like to have this a positive. Cut this in half at -1. -1 squared is plus 1. If I add 1 over here, I'm going to add 1 over here. Now this is completed. X minus 1 all squared. And here we have 3y minus 9. Factor the 3 out. Okay, there's our vertex. 1, 3. 1, 3, right there's the vertex. Right here is the 4p spot. So 4p equals 3, so now my p is 3/4. Okay, it's positive, it means it's going up. So the focus is 3/4 above that, so there's the focus. It's over 1, and then it's 3/4 more. So the focus is over 1, up 3 3/4. The directrix then is down 3/4 from that vertex. Okay, it's crossing the y-axis first of all, and it's 3/4 under that, so that will be at 2 1/4. Okay, so I know it's going to look something like this. Now, I don't really have to find the zeros because I know it's opening up. If it's opening up, it's not ever going to cross the x-axis. This one has no zeros. If I wanted it, that means it's going to have a negative under the square root. If I wanted to see that, I would solve this for y. Up here I have 3y. I'm going to put everybody else on the other side. That'll be x squared minus 2x plus 10. Putting everybody to the other side, dividing by 3. So I have 1/3 x squared minus 2/3 x plus 10/3. If I put all that in the quadratic formula, it's going to be imaginary. 1/3. B is negative 2/3. C is 10/3. See, they're imaginary. And there we have it. That's number 4. Okay, give those a try. There's 8 of them for you to try.